Hello. Today we will be telling you a little bit about our project to redesign an electric coffee grinder for easier manufacturability. I am Nathaniel Lisinski. Also speaking will be Joseph Otto, Tim Buckner, James Lawrence, Joseph Mascalo, and Alec Noon. We will be telling you about our process to choose our avenues for possible redesign. To tell you about our product as a whole is Joseph Otto.
The product we were doing an analysis on to potentially redesign is an electronic coffee grinder. Coffee grinders take raw coffee beans and mill them until the bean is in a fine powder. This process accentuates the coffee and brings a unique and desired flavor to the coffee. This has grown in popularity lately and is a more common household item. This is why our target customer group is the average homeowner, and our other customer group is non-commercial coffee houses. This is mainly because large commercial coffee houses usually have a pre-ground mix that they use. For the functional analysis, the primary function of this product is to grind coffee beans. The secondary sub-functions of this are to deposit the grinds, control the grind, assure dependability, assure convenience, enhance the product, and please the senses. For control grind, this branches into physically containing the beans and variable speed that could affect the grind. For convenience, this branches into ensuring cleanliness and adjusting the amount that this can dispense or grind.
Here we have the bill of materials. This was generated by taking apart an electric coffee grinder to be able to see what was inside. Once that was done, we did our research to find comparable products that would give us insight into how much each component cost. Furthermore, we used what we've learned in this class to estimate the assembly cost of the unit. This led us to the total cost being around $9.35, which is near 70% of the unit's value at $15. Shown here is an exploded view of the primary components of the three main subassemblies of the Amazon Basics coffee grinder. The three main subassemblies for this product are the base assembly, the motor assembly, and the container assembly. As you can see, the coffee grinder was designed with a preference for Z assembly. The base of the assembly is constructed first, and then the motor assembly is inserted and fastened from the top down, and finally the container components are inserted and fastened from above.
We looked at two possible assembly sequences. Assembly sequence A builds a coffee grinder with a base plate as a primary starting point. Assembly sequence B uses the outer shell as a starting point. Sequence B has a few more assembly branches to accommodate this path. Using a grading rubric of 1 to 3, we graded each sequence in ease of transferring and handling, ease of locating parts, ease of fastening, ease of testing subassemblies, and ease of assembling in parallel. 3 is viewed as the best, 1 being the worst. The highest score between the two sequences is viewed as the better sequence. Sequence A benefits from building the internal parts first before closing it up with the outer shell and lid with a total score of 109. Sequence B is hindered by the tight spaces and difficulty of locating parts and joining as they are brought together. The total score for Sequence B was 89. Comparing the total scores, Sequence A is the better option.
This table here is a functional component mapping matrix, which shows the different functions each part on the bill of material is responsible for supporting. The list of functions comes directly from our product's functional analysis breakdown, where we use the bottom tier leafs as our functions, which the product must support. The component list comes from the product's bill of material, and each part is mapped to a required function. This table serves as an overview for each component's functional responsibility.
As described earlier, our two customer groups are the average homeowner and the non-commercial coffee houses. These users are very similar in that both require grinds to be deposited, ease of insurance of cleanliness, dependable, and please their senses through touch and feel. The architecture varies for the two groups and what will satisfy their consumption needs, with the non-commercial coffee house obviously needing more material to go through the grinder. Based on this, items that were identified as the module and the mapping matrix could be used to help differentiate the product for the two different groups. As previously described, the module parts are going to be used to help differentiate the product enough to meet both sets of customer groups' needs and wants. Platform parts are as follows, and some work will be done upon the base assembly to try to eliminate all the fasteners and clips for wire management.
In order to cater to different customer groups, we will offer both high-capacity grinders for commercial applications and small portable grinders for personal use. The main differentiation between the two is in the bowl and lid assemblies. If we take assembly sequence A from above and rearrange the order such that the bowl and lid are assembled and inserted at the end, the two products can share an assembly line through a majority of the process.
Moving on to our product variants. we have two grinder redesigns that target our two different customer segments. Our primary redesign focuses on eliminating unnecessary cost-driving components, making the design more modular while reducing the product price without sacrificing functionality. This design targets the average homeowner with its compact, budget-friendly design and ease of use. Our secondary design carries over these cost-reducing features, while also incorporating a higher volume grind bowl for added functionality at relatively the same price. This design is for the non-commercial coffeehouse owners who may need to satisfy higher demand for ground coffee beans, spices, or similar products. Both designs feature a threaded plastic bowl that eliminates the need for mounting to the motor housing. We have also redesigned the base to include a curved groove slot to secure the wire harness without a securing clip and fasteners. These changes allow for more modularity in the bowl capacity. Since the primary and secondary designs can share all of the same components, we can simply swap in differently sized grind bowls. Thank you for listening.